Right, one of the most useful tools you can have on a metalwork lathe is undoubtedly this toolpost drill. This is one that I made some time ago. It's a heavy duty toolpost drill, and I use it for drilling, milling and various other operations on the lathe, and I'm really pleased with the performance of it. And you can see how I made that if you watch one of my previous videos. But today I'd just like to show you this new design. At the beginning of the video you saw these in use, and the great thing about these tools here is that you can actually buy them already made. And they're really excellent quality, made of anodized aluminium. They have quick release for the flexi drive. They have two roller bearings in, one at the back and one at the front, similar to my design, and they come in this form as a flexi drive to be used with the Hilda die grinder or electric drills. And they come in two different sizes. This one has a 0 to 4mm Jacobs type chuck on the front with a key, and this one is 0 to 6mm. And they have a neat quick release type of flexi drive. You can just pull it off and then put it back on. There's a little tab on the spindle there which you have to line up in a slot on the inside of the handle, and then once it's lined up you just push it home, and it seats this ball here. This is a spring clip here with a ball, and that goes into a groove, a ball groove on the actual flexi shaft. Very good design and quick and easy to take off and put back on again. And it was because they came off like this that I thought about making it into a toolpost drill. Now, the Hilda die grinder is an excellent power tool. It's very well made. Several people have done reviews on it and shown how good it is, and I'm actually really pleased with it. And for the die grinder I got this ball joint stand. It says it's a universal stand. I'm not sure exactly whether it's actually meant for these die grinders, although I have seen a picture of this one holding power drills and these type of die grinders. But when I got it, it came with two rubber bushes that go in the center there, and obviously are used to clamp a different size to the actual diameter in the actual aluminium part. But I found that either that one or the rubber pieces wouldn't fit this die grinder, and therefore I had to make up my own bush. And I did that by turning a piece of dense PVC, grey PVC it is, and it's about 21mm long. The smaller diameter is 42mm, and then the inner diameter here is actually bored to fit the actual Hilda die grinder. And I have another similar die grinder with a different make on it, and I've noticed that that one is actually a different diameter to this one. So you have to actually bore it to suit whatever diameter die grinder you have. Mine one turned out to be about 36mm. And on the Hilda die grinder, it doesn't help, but the diameter here is slightly tapered, only very slightly. You can get away without actually boring the taper on the bore. I just guessed it roughly, and it fits really nice. And then the actual diameter, overall diameter size here for the actual diameter that sits in the groove on the stand, that is 44mm. And it's about 4mm wide. So like I said, they're very easy to make up. You don't have to be too fussy on the diameters. And then when it's done, I split down with a hacksaw. So that one just slides on the front of the hilder there. And then when it goes into the stand, put this diameter here in the central groove. It's all a bit fiddly at first because I'm trying to hold it for the camera as well. Hold it all together, tighten that up nice and tight with this butterfly nut, and that one's absolutely solid in the stand and perfect for this tool post drill use. And you can just stick it on a table like this and just use it with the flexi drive shaft like this, and that's great because there's a tendency when holding the die grinders to actually cover up the air intake here, and that in turn makes the die grinder too hot too quickly, and using it with one of these keeps it nice and cool. The Hilda die grinder comes with a nice set of diamond burrs, all different shapes and sizes in there, and a nice set of different accessory tools like drum sanders, stainless wire brushes, various different burrs, grinding wheels, polishing wheels, and all different things in that box. Nice little box as well to keep them all in. Plus it comes with a plastic or perspex guard. When it's out of the actual stand, you can put that one on the front, lock that on, and you can use this when you're actually sawing steel or whatever, or grinding, so that you don't get sparks in your face. So to use one of these as a tool post drill, you need two basic items. You need the tool post vise. This is a 3-inch round vise which I bought on eBay. I drilled a couple of extra holes down the bottom here to accept 6mm Allen bolts so that they go in flush against the back face. That's bolted onto a piece of 12mm square section mild steel bar to a certain length, and it's put in the tool post like this so that you can actually slacken off the tool post locking nuts, and you can actually slide the vise backwards and forwards to gain enough clearance, especially on the mini lathe, when you're going to use the tool post drill. And the other thing you need is this simple welded fixture. And all that it's made from is a couple of pieces of angle iron, a couple of sections of mild steel flat bar, and a couple of brass pieces of tube, and two 6mm stainless steel Allen bolts. And the tool post, or the drill handle, goes in there like that, and all this you do is tighten these down, and it actually locks it down on the handle, and it's ready for use. And once it's in there, you can actually leave it set up for whenever you need it. So that's what the fixture looks like in pieces. And these are the pieces of steel that you need to make it. A piece of mild steel, 125mm long times 30mm wide and 5mm thick. Some 3mm angle iron, one piece is 70mm long, and this piece is 60mm long. And like I said, it's 3mm thick, and it's 1-inch angle iron. And a piece of mild steel that's 70mm long by 18mm wide, and this is 6mm thick. And then you need brass, steel or aluminium tubing that will go on stainless steel screws, 6mm stainless steel screws, and these are 50mm, yeah, 50mm long. And to make the fixture, you clean up all the steel and then lay this on a nice hard surface. I lay mine on my welding bench, which is about 20mm thick aluminium table. This piece will lie in the centre of that. I'll put it around the other way so it's easier to see. So that angle iron butts up against that piece there in the centre. Then you put this piece on the angle iron, and then all as you do with an arc welder is weld down this piece here all the way down, and then all the way down the top here on the apex of the angle iron, and that piece makes it really solid, and when it's welded up it looks like that, absolutely solid. So next I got my knife scribe and set it for 24mm to the point, and from this side here I scribed down for the centre of the 6mm threaded holes. That's quite critical, 24mm from this side to the centre of the holes. And then I set it for about 43mm and scribed in from each end to get the X for drilling those. Centre punched those, drilled those with the core diameter for 6mm thread, and then tapped those with the 6mm tap. I then got some thick brass tubing that fits the 6mm Allen bolts, and I cut two pieces off and then faced off both ends so that they're each 9/15 thou long. So it's 0.915, and you must get those very close, and I'll explain why in a minute. I next got a piece of 30mm wide mild steel. I don't think I mentioned this in the list of materials needed at the beginning, and I lined those up and drilled for the 6mm Allen bolts. Made those a little bit oversized so that when it clamps down it can centralize itself. And imagine this isn't welded together at the moment. I put the handle of the tool in here. I put the two brass bushes in between. Put the Allen bolts in there like that. And then just nipped those up to actually lock that piece of mild steel with the apex of the angle iron held in place like that. I nipped that up, and this is where the brass tubing is important that it's both exactly the same length, so that when you nip those Allen bolts up it pushes down squarely on the angle iron on the apex there. And while doing those two up, check that the angle iron is nicely pointed up, directly up from the back there. So the gap either side here is equal, and you can see that it's correct. I then put this in a vise, and again I welded down through the V where those two pieces of metal join from the back here, and then I took the welded part off, put it in the vise again, and make sure I filled that V up with plenty of weld to make it nice and strong. And if it all went well with the welding and it's all correct, when you put it back together again and tighten the Allen bolts up, you can see clearly that it's locked onto the diameter at the back here as well as the front. So that's really important to actually get those spot on length. And one thing I just mentioned here, when I was welding this, I did actually splash a bit on my anodize, and it took some of the anodize off. I sprayed over it with a bit of orange paint, but it's best to actually get a diameter of bar exactly the same size as the handle and hold in there to do the first part of the welding. So that's basically the fixture made, and then I just drilled through and countersunk for I think it's 4 BA screws. You can use whatever screws you like. It's best to drill and countersink these holes, and then I put a piece of packing on the underside here. I put on 6mm mild steel bar, and all that is to get the optimum position on the actual holder. If you've drilled and mounted the vise exactly the same as mine, then you'd need that piece of packing. If you've done it differently, you might have to use a different thickness of packing. All it is basically to get the, like I say, the optimum position when that's actually locked in the vise, that this adjustment of height is not too far up or not too far down. Try and get it sort of reasonably midway, and then you'll have plenty of adjustment to get everything on centre, and nothing will be on the limits. So to finish off, I'd just like to show you quickly how to make this direct drive for a power drill to go on. This spring clip here, you have to remove the spring clip. It's quite easy. Lever it up a bit and just slip that off. The ball bearing comes out, put those in a safe place. This is the hole where the ball bearing sits, and obviously goes into that ball groove on the flexi shaft. So then you unscrew the back end here. I didn't have to use any pressure at all. They seem to be only hand tight. Unscrew that one there, and this is the adapter that I've made out of brass. Fits nicely through the hole there, and all it is a couple of Allen keys up this end here, and they actually tighten into the groove that I was talking about earlier. That's the slot for the actual tab of the flexi shaft to go in, that I showed how you line that one up and push that one down first before you can actually put the flexi shaft into the ball groove. Basically a couple of Allen bolts in line. That one pushes down over that shaft. It's a nice close fit. Everything's running concentric, and just tighten those Allen bolts into that slot, and that's nice and tight. You can actually put a bit of Loctite on those so that they don't come loose. This is just a 6mm Allen key piece cut off of an Allen key with a grinding wheel and drilled out, and then this one is actually knocked into that with a bit of Loctite 638, and that's the drive for the tool. So they're nice and easy to make up. The next one I make, I think I'll make out of stainless steel, and I'll probably show that one being made at some point. Make them up with whatever material you like, and that's how easy it is to make the direct drive. So basically the front diameter of that adapter is 664 thou. The shaft that goes through the back end of the handle is 3/85 thou. There's no need to have that recess there, and the whole thing just is made to so it actually just sticks out the back like that, and like I say, it must be a nice close fit over that shaft, and that's about it. And just before I go, I'd just like to mention with this Hilda die grinder as well, you get a spare set of brushes, which is excellent, and I hope you see how useful these tools are for tool post drills and all their other excellent uses.